All right, so ready to dive deep into this reinforcement learning thing. RL, right?
Yeah, seems like it's everywhere these
I
days.
know, right? Got to stay on top of the hype. And this is fascinating. This research paper, it's like a whole RL encyclopedia.
Dense, for sure.
Yeah, but mind-blowing. The stuff they're doing with AI now, it's like
Well, it
crazy.
is. It really is. So RL, at its core, it's about letting computers learn by doing, like just like we do, right?
Instead of just programming every single rule, huh?
Exactly. You set up the system where they get rewarded for good choices, penalized for the bad ones.
So they learn over time.
Yeah, they figure out how to just be amazing at whatever you throw at them.
Okay, that makes sense. But like, how does a computer even know it's good or bad?
Yeah.
Are we talking like thumbs up, thumbs down emojis here?
Not quite, but you're kind of on the right track. It's all about this thing called a reward function.
Reward function.
Yeah, imagine training a dog. You give it treats for sitting, staying, fetching. Those are the rewards, right? In RL, we program these reward functions into the system. So if our AI is playing a game, maybe it gets points for, scoring or completing levels.
Oh, so it's like a built-in motivation system.
Yeah.
Got it. But, I mean, it's got to be more nuanced than just like points mean good, right? Life's not always that straightforward.
Absolutely. There's this whole concept of like delayed gratification,
Oh, yeah.
which in RL, we deal with using something called a discount factor.
Discount factor. Do I need my calculator for this?
No calculators needed. Think of it this way. Do you always go for the quick reward, or can you hold out for something better later?
Oh, I see. Like patience.
Yeah, someone with a high discount factor is playing the long game, willing to sacrifice a little now for a big payoff later.
So like investing in a retirement fund instead of, blowing it all on shoes.
Exactly. And we can actually tweak this patience level in our AI agents.
Oh, really?
A high discount factor makes them strategic, focused on the long term. Low discount factor, they become impulsive, going for those quick hits.
Interesting. So we've got our AI motivated, learning from rewards. But how do they actually figure out what actions to take? It can't just be random, right?
Definitely not random. There are two main ways AI learns in RL, model-free and model-based.
Okay.
Imagine you're dropped into a brand new video game. Model-free learning is like mashing buttons, seeing what gets you points, and adjusting. You're not trying to understand the rules, just reacting to the feedback.
Sounds like my strategy for most video games.
Well, it can be surprisingly effective. Q-learning, one of the classic RL algorithms, works this way. But then there's model-based learning, which is more strategic. It's like actually studying the game's manual, figuring out the mechanics, then planning your moves.
So it's like building a mental model of the game world.
Precisely. Think of using a map to navigate a city. You understand the layout, the landmarks, and that lets you plan the most efficient route.
Okay. So not just games then.
Right. Both approaches have their pros and cons. Model-free is simpler to get started with, but can be slow, inefficient. Model-based is powerful if you have a good model of the world, but building that model can be tricky.
Right. So it's like choosing the right tool for the job.
Exactly. And then on top of all this, there's this constant dilemma about exploration versus exploitation.
Ooh, that sounds interesting. Tell me more.
Think about your favorite restaurant. You know you'll enjoy it there. That's exploitation.
Right.
But what if there's an even better restaurant out there that you haven't discovered yet? That's the allure of exploration.
Yeah, true. But then you risk wasting time and money on a bad meal. It's a tough call.
Exactly. AI agents face the same dilemma. They need to balance between using what they know to maximize rewards, exploiting,
Right.
and trying new things to
Yeah,
potentially find even better strategies,
Yeah.
exploring.
Got it. So how do they decide, when to stick with the familiar versus venture into the unknown?
Well, there are different techniques. One common approach is to add a bit of randomness to their actions, like flipping a coin to decide if they should try something new. This randomness helps them break out of ruts, helps them discover hidden gems.
So even AI needs a little spontaneity in its life.
It's all about balance. Too much exploitation and they get stuck. Too much exploration, they waste time on dead ends. It's a delicate dance.
And all this is just like the tip of the iceberg, right? We're just scratching the surface of what RL can do.
Absolutely. We haven't even touched on things like, deep reinforcement learning, where we combine RL with the power of neural networks. That's where things get really wild. We're talking AI that learns to play video games from pixels, control robots in complex environments, even design personalized medical treatments.
Wait, from Pac-Man to personalized medicine, that's a big jump.
It might sound crazy, but that's the potential. a whole new way for machines to learn and adapt. We're only just beginning to explore the possibilities.
Okay, color me intrigued. We need to delve deeper into this deep reinforcement learning thing. But before we do, let's rewind a bit, unpack some of these core concepts. I want to make sure we have a solid foundation before we get into the really wild stuff.
Sounds good. Let's start with those two main learning approaches we talked about, model-free and model-based. They're the building blocks for everything else.
Okay, listeners, buckle up. We're about to get a little technical, but trust me, it's worth it. Stay tuned.
So model-free learning, it's all about trial and error, reacting to feedback and refining your strategy as you go.
Got it.
Think of it like learning to ride a bike.
Okay.
You don't necessarily understand the physics behind balancing, but you keep trying,
Right.
adjusting your movements based on whether you stay upright or, wobble.
Makes sense.
And one of the most popular algorithms in this category is Q learning.
Q learning.
It's all about figuring out the Q value,
Okay.
taking certain actions in certain situations.
It's like creating a mental cheat sheet for navigating the world, right? Like if I do this in this situation, how good will the outcome be?
Exactly. And these Q values are constantly being updated based on the agent's experiences.
So it's like a never-ending learning process.
It is. It's refining those estimates with every action and every reward.
Okay, that makes sense. But earlier you mentioned deep reinforcement learning.
Right.
How does that fit into all of this?
Well, imagine instead of a simple cheat sheet, our AI has access to a powerful neural network.
Okay,
That's deep reinforcement learning in a nutshell.
got it.
It lets us deal with much more complex information like images, videos, even sounds,
Wow.
and learn strategies in those environments.
So it's like upgrading from a basic calculator to a supercomputer.
That's a great analogy.
Thanks.
And one of the breakthroughs in deep RL was the development of deep Q networks, or DQNs.
DQNs, those are the ones that mastered Atari games, right? Just from looking at the screen.
That's right.
That's amazing.
Instead of a simple Q table, they use a deep neural network to approximate those Q values.
Yeah.
This network takes in the raw sensory data, like the pixels on a screen, and outputs estimates of how good different actions would be in that situation.
So it's like the AI is learning to see and understand the world in a way that traditional Q learning just couldn't.
Exactly. And this opens up a whole new world of possibilities.
I bet.
We're no longer limited to simple, well-defined environments. We can start tackling problems that are much closer to the messy, complex world we humans live in.
That's pretty incredible. But I'm guessing training these DQNs is a whole other level of complicated.
It definitely can be.
Yeah.
These neural networks are complex beasts with millions of parameters that need to be adjusted just right.
I can imagine.
But researchers have come up with some clever tricks.
Like what?
Well, one of them is called experience replay.
Experience replay. Does that mean the AI is like reliving its past glories or something?
Kind of. Imagine the AI has a memory bank where it stores all its past experiences.
Okay.
The states it encountered, the actions it took, the rewards it got. During training, it randomly samples from this memory bank and learns from those past experiences again and again.
So it's like reviewing game footage
Yeah,
to analyze past plays and strategize for the future.
exactly. This helps the AI learn more efficiently and avoid getting stuck in ruts.
Right.
It's one of the key ingredients that allow DQNs to achieve those amazing results on Atari games.
Okay, so that's model-free learning, reacting to feedback, learning by doing.
Right.
But what about model-based? We talked
Yeah.
about building mental models of the world.
Right.
How does that actually work in practice?
In model-based RL, the focus shifts from reacting to planning.
Okay.
Instead of just trying things out and seeing what happens, the AI tries to build an understanding of how the world works.
So it learns the rules of the game.
Yeah, a perfect analogy. And with that map, the AI can start to plan its actions more strategically.
I see.
It can simulate different scenarios,
Uh-huh.
predict the consequences of its choices, and choose the path most likely to lead to its goal.
That sounds incredibly powerful.
It is.
But building those models, I'm guessing that's not easy.
It definitely can be a challenge.
Yeah.
The world is a complex place, and capturing all the nuances and interactions in a model is no easy feat.
Right.
But there are some fascinating approaches out there.
Like what? Give me some examples.
Well, one classic algorithm is called DINA.
Dinah.
It's a sort of hybrid approach combining elements of both model-free and model-based learning.
A hybrid approach. How does that work?
It learns from real experiences, just like Q learning,
Right.
but it also uses those experiences to build and refine a model of the world.
Mm-hmm.
And here's the clever part. Dyna can use this model to generate simulated experiences,
Oh, wow.
which it can then use to further improve its policy even without interacting with the real environment.
That's like practicing in a virtual reality simulator before tackling the real deal.
Exactly. And this ability to learn from both real and simulated experiences makes Dyna a very powerful and efficient algorithm.
Cool.
It can adapt more quickly to changes in the environment and explore a wider range of possibilities.
Okay, Dyna sounds pretty impressive, but are there any algorithms that focus purely on building these world models, like really detailed simulations of reality?
Absolutely. And this is where things get really interesting.
Okay.
We're talking about algorithms like Dreamer and MuZero, which use deep neural networks to create incredibly sophisticated world models.
Dreamer and MuZero, those names sound like they're straight out of a sci-fi movie.
They do, don't they? But the technology behind them is very real.
I believe it.
These algorithms are pushing the boundaries of what's possible, with AI allowing us to tackle problems that were once considered too complex for machines.
All right, I'm hooked. Tell me more about these world-building algorithms.
Okay.
What makes them so special?
Well, let's start with Dreamer. It's all about learning a compressed representation of the world, kind of like creating a highlight reel of the most important information.
A highlight reel for AI, so it's not trying to model every tiny detail, just the stuff that really matters.
Right. Dreamer uses a type of neural network called a recurrent neural network to capture the essence of how the world changes over time. It learns to predict what will happen next based on what's happened before, and uses that information to make decisions.
Okay, so it's learning the patterns and the rules of the game, but in a more compact, efficient way.
Exactly. And what's amazing is that Dreamer can actually use this compressed world model to plan its actions, even without interacting with the real environment. It's like playing out different scenarios in its head before making a move.
So like a built-in strategy simulator.
That's a great way to put it. And this ability to plan and strategize using a learned world model is a huge step towards more intelligent and adaptable AI systems.
Okay, Dreamer sounds pretty incredible, but what about MuZero?
MuZero takes a slightly different approach. Instead of trying to model the world in all its detail, MuZero focuses on learning a model that can predict the value of different actions in different situations.
So it's like learning the strategic importance of different moves in a game without necessarily understanding all the visual details.
Precisely. MuZero uses a technique called Monte Carlo tree search to explore different possible futures and figure out which actions are most likely to lead to success.
Monte Carlo tree search, that sounds familiar.
It's a powerful search algorithm that's been used to achieve superhuman performance in games like Go and chess. By incorporating this into its learning process, MuZero can plan strategically and make decisions that maximize its chances of winning, even in incredibly complex games.
Wow, that's impressive. So both Dreamer and MuZero are using world models to plan and strategize, but they're going about it in slightly different ways.
That's right. Dreamer is more focused on building a detailed simulation of the world, while MuZero is more focused on learning a model that can directly predict the value of actions. Both approaches have their strengths and weaknesses, and researchers are still exploring the best ways to combine them.
Okay, so we've got these amazing world-building algorithms, but, it makes me wonder, isn't there a risk that these AI agents become too focused on maximizing rewards, even if it means like cutting corners or bending the rules?
That's a great question, and it's one that researchers are very aware of. Remember, we talked about reward functions earlier. Well, designing those reward functions carefully is crucial. We need to make sure that we're rewarding the AI for the behaviors we want to see, not just for achieving the goal by any means necessary.
So it's not just about reaching the destination, it's about taking the right path to get there.
Exactly. And this is where things like ethics and values come into play. We need to make sure that we're instilling the right values in our AI systems so that they make decisions that are aligned with human values.
That's a huge responsibility, but it's also incredibly exciting. We're talking about creating AI that can learn and adapt, but also make decisions that are ethical and beneficial to humanity.
It's a challenge, but it's one that I believe we're up to. The field of reinforcement learning is advancing rapidly, and we're constantly developing new techniques and approaches to ensure that AI is used for good.
Okay, I'm feeling inspired, but before we wrap up, I want to circle back to something you mentioned earlier,
Yeah.
the connection between RL and language models. How are those two worlds colliding?
Well, we're seeing some really exciting developments in that area. For example, researchers are using language models to generate a more informative reward functions. Instead of just giving the AI a simple numerical reward, we can use language to provide more nuanced feedback like, good job, but try to be more efficient next time.
So it's like coaching the AI, giving it more detailed guidance.
Exactly, and this can lead to much faster and more effective learning. We're also seeing language models being used to create more comprehensive and interpretable world models. Imagine an AI that can not only predict what will happen next, but also explain its reasoning in natural language.
That would be amazing. It would make these AI systems so much more transparent and understandable.
It's still early days, but the potential is huge. We're on the cusp of a new era in AI where language and action are seamlessly intertwined, and reinforcement learning is at the heart of it all.
This has been an incredible journey. We've covered so much ground, from the basics of RL to the cutting edge of world models and language integration. I feel like I have a whole new appreciation for the power and potential of this field.
It's been my pleasure.
And to our listeners, thank you for joining us on this deep dive into reinforcement learning. We hope you learned something new, sparked your curiosity, and maybe even glimpsed the future of AI. Until next time, keep exploring, keep learning, and keep diving deep into the world of knowledge.